Hi, Stats. Stirrup here. It's now Thursday. I get to be at this meeting again. Yay. And then Friday I'm taking off because it's my new house stuff to take care of. But I look forward to seeing you guys on Monday. But take a look at running through page 129, 130. So all you really have to do on page 129 is if you go onto your stats and hit that chi-square distribution. So they said your degrees of freedom is 8. So we just change that to 8. So this is problem number 1 on page 129. And then we change that is greater than 20. So then I'm going to change this, go all the way out to 20. And so if you scroll down, our S value is 0.01. So that's totally tiny. This graph is way off to the right. So you can barely see that right there. And then for problem number 2, find the proportion degrees of freedom 15. So just come up here, change your degrees of freedom to 15. And then greater than 20, so we're still there at the same thing. So our S value is going to be 0.17. So it grew a little bit. And then find the proportion degrees of freedom of 25. Well, we only go up to 20 here, so just take it to 20, and then less than 20. So we want to go the opposite way. So what we'd want to do with this is I would actually go 1 minus 0.46 to get 0.54, and that would be the answer to number 3, because if we were going to the left, that would be, or less than, that's where we need to take it. Okay. Take a look at number 4. It says Netflix has 11 movie categories: drama, horror, comedy, and they wish to test whether the distribution of the movies it rents has changed from 2010. They conduct a chi-square test to obtain a chi-square test statistics, sum of all, and they tell us that the sum of our chi-square test, so they've already gone through the math, has been this. Okay, state the null and the alternative. So the null is movies is the same, and then our alternative, our movies are not the same, as far as the categories go. They broke it into drama, comedy, horror, and etc. So if we wanted for number 5, for how many degrees of freedom would be 3, because it's 1 less in our categories. And then calculate the p-value, and so we can go ahead and do that. They already gave us this 23.6, which is fine, and we'll see if this comes out a little bit better. I think we can actually change these. Let's see, our degrees of freedom on this one we said was 3, so I'm going to bring it back this way. And we are going to have that, right now they're saying that we want that p-value. Well, they gave us the sum back on the other one as 23.6. We can't get quite to 23.6, but we'll be okay with 20. So we're going to have a p-value of 0. And so if we use an alpha of 0.04, 0.04 is a larger number than 0. So that means that we would reject our null hypothesis, meaning we found strong evidence that our movie choices have changed as far as Netflix goes. Number 8, would a higher chi-squared statistic make it easier or harder to reject the null hypothesis? Higher chi-squared makes it harder. The bigger the difference from your mean, the more unlikely it is to take place. And then, are the assumptions met? So 7.3, on 7.3, the only 2 assumptions, the sample size is large enough. So and I'm looking on page 53, it says, in a chi-squared test, this is met when all of the expected values are greater than 5. So we can't necessarily see that. And then the random sampling, we must assume that each box is randomly chosen from the population at large, but that would usually be told to you in this. So let's pull over to page 130. 130, they talk about wildlife officials monitor changes in the ecosystem of state parks. In Cherry Creek State Park, the distribution of snakes is thought to be as follows. So we have the snakes. We have the garter, the bull, the racer, and the rattlesnake. Okay, and they feel that there's 60% of these. So this is the expected value. 60%, 20%, 10%, and 10%. And then they go through and they basically count up all the snakes. So we have to add those values up. The 38, 25, 7, and 4. So we had a sample of 74, and we don't know if it's random. Maybe it was random or not. But they found that they observed that there was 38, 25, 7, and 4 of those snakes. Okay, so let's conduct the null. So for number 10, state the hypothesis. So our null snakes are equal to the expected, and the alternative snakes is not equal to the expected. And then make our chart. So then we can find our chi-squared. Remember, our chi-square is the observed minus the expected, quantity squared over the expected. So if we run through the math, you have observed 38 minus 60, quantity squared over 60. This one we're going to get 25 minus 20, quantity squared over the 20. For the racer, you're going to get 7 minus 10, quantity squared over the 10. And for the rattlesnake, we're going to get 4 minus the 10, quantity squared over the expected. So if we take a look at those, these should work out nicely. So I get 38 minus 60, and we're going to square that, 484 divided by 60. So this is going to come out to 8.1. 25 divided by 20 is 1.25. That's what that's equal to. 9 divided by 10 is 0.9 for the racer, and then the rattlesnake, I get 36 divided by 10 is 3.6. So if we sum up all these, this is my chi-squared sum up. So I'm going to go 8.1 plus 1.25 plus 0.9 plus 3.6. So that's going to give us 13.85. And then let's calculate the p-value. So we're going to go back into our Desmos. Okay, so we had 4 different snakes, so our degrees of freedom is going to be 3, and we came out to 13.85, so it's going to be like 13.9. So we bring this down to like 13.9. So about there. So this gives us a chi-squared value of 0. Okay, so it's a really small decimal. So that is less than our p-value of 0.1. So we get basically our p-score is equal to 0. It's such a small decimal. So that p-value, if our p-value is less than 0.10, this means that we would reject our null, okay? And that reject our null, we found strong evidence against our null, against the null. So that's how you kind of cancel it out. Okay, so what I plan to do today is let's walk through page 131, 132. This would be a good review for our little quiz that we have on Friday. Again, that quiz, don't stress about it. If you're writing the stuff down, you have everything available for you. So on page 131, it says, for each of the hypothesis tests, show every step, procedure, null and alternative, table observed. Okay, we got all that. All right, so they feel that there's heart attacks are more, happen. So we have winter, spring, summer, and fall. And these are heart attacks. heart attacks. This is our observed. So there was 110 heart attacks here, there was 92 here, 122 here, and 96 in the fall. So that basically means our sample that we did, if we add those up, gives us our sample. So plus 122 plus 96. So there's 420 as our sample set, and you're allowed to giggle at the 420 like they would in Algebra 1. All right, so what we would expect is we would have 25% in each season. Like no season would have more heart attacks than the other. Okay, so our null is heart attacks equal to expected, EXP. Our alternative is heart attacks not equal to the expected. Okay, so let's figure out what are expected. So if we had to take 420 times 0.25, so that means that we would expect to have 105 heart attacks during each of our seasons. Okay, so now if we want to find our chi-squared, remember our chi-squared is equal to observed minus expected quantity squared divided by the expected. So on the first one, I'm going to go, we're going to go 110 minus 105, that's 5. 5 squared is 25. 25 over 105, so 25 divided by 105 comes out to 0.24. And then on this next one, I'm going to be observed. So I'm going to go 92 minus 105. I'm going to square that, which is 169, divided by 105. So that's going to give me 169 divided by 105, which in this case is going to come out to 1.61. And then I'm going to do observed minus expected, 122 minus 105. We're going to square that. So that's going to give me 289 over the 122. Oh, you know what? I think I made a mistake. Oh, no, I made a mistake right here. That should have been a 105. I'm sorry. So 289 divided by 105 is 2.75. And then the last one, we're going to go observed 96 minus the 105. And we'll divide that. We'll square that. So that's 81 over 105. So 81 divided by 105. So that's going to give me 0.77. So we're going to sum these up. So my chi-squared summed up. Just add all of these values together. So 0.24 plus 1.61 plus 2.75 plus 0.77. So that's going to come out to 5.37. So let's just round that to 5.4 for our sliding scale. And then we're going to go on to Desmos. So we have 3 categories. So my degrees of freedom will be 3. My degrees of freedom are 3. We already have that. And we want 5.4 for my R value. So we're going to bring this back to 5.4. So we come up with 0.14. 0.14. So that's basically our p-value is 0.14. Well, they didn't tell us anything there, so we're going to assume that our p-value, if it's less than 0.05, okay, that would be a rejection of the null. This case, this is bigger. This is bigger. So we're going to fail to reject our null. We didn't find strong evidence against the null. Okay, so that's page 131 for you. All right, 132, something we don't want to deal with, says, have the nature of football injuries changed from these recent years? A study shows that in year 2000 showed the following distribution of the injuries. So you have knee, head, neck, shoulder, foot, ankle, hand, back, and other. And then a random sample of 220 football injuries is conducted. Okay, so on page 132, our null and our alternative, we could say injuries equal expected, and then injuries are not equal to expected with our alternative. And so we know that we have types of injuries. We have knee, we have head, neck, shoulder, foot and ankle, hand, back, and then other. And so they had shown the percent of injuries. This was 28%, this was 24%, this was 20%, this was 15%. So going here, 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 12% here, and other was 11%. Remember, they told us that we did a random sample of 220. So what we could do is we could actually find out, go 0.28 times 220. So this is 61.6 injuries here. We can go 0.24 times 220. So that's going to give me 52.8. And then I'm going to go 0.20 times 220. So this gives me 44. And then 0.15 times 220. That's 33. 0.12 times 220. That gives me 26.4. 0.11, so 11% times 220 gives me 24.2. Okay, so these are the expected based on 220. And what they observed with that is they observed there was 52 injuries here, 60 here, 42 here. So these are going all along with these. 33, that goes to 36, 20, and 10. So then we want to look at our chi-squared. So remember, our chi-squared is going to be the observed minus the expected, quantity squared divided by the expected. So let's go ahead and figure the chi-squared out for each of these. So observed 52 minus 61.6, square that quantity, and then divide by my expected 61.6. So this comes out to 1.5. And then I'm going to go observed 60 minus 52.8 squared. And we're going to divide that by our expected of 52.8. And then that's going to come out to 0.98. That's 1.5 right there. And then I'm going to go observed minus expected. We're going to square that. So that's going to give me 4 divided by 44, which is 0.09. Then I'm going to do observed minus expected. That's 3. Square 3, get 9. 9 divided by 33. Adios. That gives me 0.27. Then I'm going to go observed minus expected. That's 6.4, square that. That gives me 40.96 divided by 26.4. That's going to give me 1.55. And then the last one, I'm going to go 10 minus 24.2. I'm going to square that. And that's going to be divided by 24.2. So that's going to give me 8.33. So if we sum all these up, add these up, add all that up, so I'm going to get 1.5 plus 0.98 plus 0.09 plus 0.27 plus 1.55 plus 8.33. So our chi-squared summed up is going to come out to 12.72. We're going to make it at 12.7, okay? All right, so now our degrees of freedom, we have 1, 2, 3, 4, 5, 6 categories. If we have 6 categories, my degrees of freedom will be equal to 5. We're going to go on to Desmos. So our degrees of freedom is 5. Okay, and then we're going to look at 12.7. So bring this up to 12.7. Okay, and that gives us 0.03 as our p-value. So our p-value is 0.03. All right, so remember, if the p-value is less than 0.05, well, this is less. So we're going to reject our null hypothesis. We found strong evidence against the null. So the injuries, according to this, we have evidence to say that it's not equal to what it had been in 2000. That's happening more often. All right, so my friends, I have covered everything that you could possibly want from 7.1 to 7.3. Okay, we reviewed it. There will be a quiz on Friday. It is on Schoology. I would highly encourage you to bring a computer, just because sometimes on your phone it's not going to work as well. Now, the nice thing is you get to do it, the whole thing, as a group. It's only 5 questions. I think you can totally handle it, and have some fun with it. Actually, do me a favor. I mean, I know that you guys have seen lots of videos. Watch the trailers to all 5 of the movies that are my favorite movies. I mean, you guys know me. Tell them, and then figure out those are my top favorite movies. So figure out which one is my number 1 movie to my number 5 movie. I mean, just have some fun with it, but work together. And please be kind to the sub. I look forward to seeing you all on Monday. Let me know if there's anything you need. Take care of one another. Bye-bye.